Hello, my name's Graham. I'm an engineer at Celtic Magic. When the G-Click was in development, the obvious advantage that it would have is its ability to automatically calibrate itself to the position of the user during daily use. Since its launch over a year ago, there have been other benefits which have come to light, and in the latest firmware, it also has the ability to ignore dystonia related spasms without producing an unintended output. That's a feature I want to look at in more detail in this video, but before I get into that, I'll take a few moments out to just highlight the other features of using gyroscopic switching for those unfamiliar with the G-Click product. The G-Click is inherently a zero force device and is detecting tilt and can have incredible sensitivity. If I mount the sensor off that clamp and I have the sensitivity turned up high and I activate the device, it will calibrate to that position in space and detect me breathing gently on it, producing tilt quite easily. I'm going to turn the sensitivity down, and its normal state of operation would be connected to a user. It doesn't have to be connected to a user, but typically would be. So if the user is using the device like that, let me turn the sensitivity right down so you can see it, and then again it will calibrate and detect, in this case, reasonable tilt. But if the user accidentally moves position, it will recalibrate, determine its new position. Within 2 or 3 seconds, it will be ready to go again in this new position, and is able to recalibrate as many times as needed during the day. If the motion continues, then the red lights will stay on until the user's hand, in this case, is settled. The other feature that's become apparent is it has no need to return to zero. With a conventional switch, a user with extremely compromised motion may be able to press a switch but unable to release a switch. The gyro doesn't care because it's looking for a rate of change of tilt, not tilt itself. So if I activate again, and I'm going to activate it down but not return, you'll see that the G-Click will detect that motion like that. I haven't returned to the original position. I'm going to continue and move down in the same direction. We'll get another output. Again, I haven't returned, and I move down and we get another output. So there's no necessity for the user to struggle to get back to an off position. Let's look at this spasm detection feature in detail. As I touched on earlier, with an uncontrolled spasmodic movement, the G-Click can readily recalibrate itself to any new position. However, such a random spasm will almost certainly produce an unwanted switched output, which can be a frustration for the user. The aim here is to reliably detect the difference between a valid switch movement and an uncontrolled spasm in just a few thousandths of a second, and prevent any unintended outputs from that spasm. The feature is not intended to deal with continuous spasmodic motion, rather it is suited to users with intermittent episodes. So let's look under the hood and see how this can be done. Inside the gyro itself, there's actually 3 gyros looking at different tilt directions. So we have one gyro looking for forward and back, another looking right and left, and a third looking at rotate. And you'll notice there's a plus and minus to each direction of tilt. Only one of these is used to actually operate the switch, and that can be configured in the G-Click configuration. Its default is that direction. But in addition to the gyroscopic information, The device also measures acceleration, and acceleration is not a tilt but is flat. It can be forward and back, it can be up and down, or it can be left and right. And it's the acceleration information that we're going to use to detect an unexpected spasm and inhibit the output from the switch. The configuration is entered by holding the button and powering the device on, and we have several menus, but the one we want is the yellow advanced menu, so I'm going to go into that one, and we can select one of 5 LEDs. The spasm feature is the fourth one, the sort of purpley pink one. And the next one up is you can use to set spasm detection, normal levels or high sensitivity. We'll leave that off, and we'll go around again and select spasm detection mode, and that's it. And now if I simulate a user or activate it, and the sensitivity is about 30%, and we'll get the device operating as before. However, if I have a spasmodic motion, you'll see it will immediately indicate all white, it's locked out, and it will stay on red until the episode subsides and motion ceases, and then the device will do an auto recalibrate and be back in service until another spasm is detected, where again it will lock out until motion subsides and go back into service. And it will go back into service at whatever position the user has ended up at.